Hello students, in continuation with our discussion on case study questions, today we'll take up electrostatics. In our previous discussion, we have taken what are case study questions and how it is different from the normal passage based questions where you have been given questions based on a particular passage to be answered. And what is the common way in which students attempt? And what is the best way to attempt such questions, which is also a time-saving one. At the same time, it also gives you more accuracy. So how we should attempt such questions on case study there, that we have already discussed in our previous discussion. So in this series, we are going to take the different topics, and today's topic of discussion is electrostatics. Let's take first case study question on electrostatics. You have been given the passage. So just let's see what is the passage there. A Faraday cage or Faraday shield is an enclosure made of conducting material. The field within a conductor cancel out with any external field, so the electric field within the enclosure is zero. These Faraday cages act as a big hollow conductor. You can put things in to shield them from electrical field. Any electrical shock the cage receives pass harmlessly through the outside of the cage. First question is, which of the following material can be used to make a Faraday cage? Now, if you just see the passage which was given there, in the passage it was given a Faraday cage or Faraday shield is an enclosure made of conducting material. So we'll just see that in this particular option, what are the options given there? One is your plastic, another is your glass, then is your copper and wood. Now, since it is a conducting one, so the copper, if you take, is the correct option. Second question, example of a real world Faraday cage is, first one is a car, second one plastic box, third one is lighting rod, and the fourth one is metal rod. Obviously, Faraday cage example, if you take a conducting enclosure there, so in that case, it is the car which is the correct option. Let's take now the third one. What is the electrical force inside a Faraday cage when it is struck by lightning? And the different options which are given, the first one is the same as the lightning, second one half that of the lightning, third one 0, and the fourth one a quarter of the lightning. Now, electrical force inside a Faraday cage, there is no effect of the charges there on the enclosure, that is the Faraday cage and other, for the things which is kept inside. So there is no electric field. So as there is no electric field there, so obviously you can consider that the force which they will be experiencing will be 0. Next question. If isolated point charge Q is placed inside the Faraday cage, the surface must have charge equal to, now the different options are given there. Now, if you see the different options, for that, let's just take, we take this as the enclosure, and here you have a charge, say Q. Say we have taken a charge plus Q there. As it is a conducting shell, so obviously on the inner side, you have the charge minus Q developed, whereas on the outer one, it will be the plus Q. Now, here, remember that if it is asked what is the charge on this Faraday cage there, net charge here is 0. But you know that as it is a Faraday cage, so the charge on the outer surface will be just sent to the earth. So here the outer surface will not have any charge, because if suppose you earth them, all these charges will disappear from the outer surface. So now if I consider the charge on this surface of this Faraday cage, in that case it will be C. Do remember that we are taking the case that it is a Faraday cage. So for that particular case, we can consider that the charge will be your minus Q. Let's now take the fifth question. A point charge of 2 microcoulomb is placed at of Faraday cage in the shape of a cube with surface of 9 centimeter each. The number of electric field lines passing through the cube normally will be. Let's consider this is the cube there. Okay, and we have a charge kept at the center of this. And this is cube. It has a side of 9 centimeter. And the charge here is your 2 microcoulomb. Now, if you want to find out what is the electric flux or the number of electric lines of forces passing through the cube, in that case, for the entire cube, if you consider, then it will be passing through all these surfaces there, different surfaces if you consider. So by Gauss theorem, you know that the total flux will be given by net flux will be given by your Q by epsilon naught. Here it is your E dot ds, integral over closed surface. This is your Q by epsilon naught. So since it is asked what is the number of electric lines of force, that means it is your electric flux, and you have to find what is the lines of forces passing through the cube normally. So in that case, it is your Q by epsilon naught. So the value of Q is already given. It is your 2 into 10 to the power minus 6, because it is 2 microcoulomb, and divided by this epsilon naught. Epsilon naught value, if you take 8.85 into 10 to the power minus 12. So that is the numerical value. And if you simplify this one, you will get this one as roughly 2.2 into 10 to the power 5 Newton meter square per coulomb square. Now, this one, if you consider, the third one is an approximate value there. So in that case, this will be the correct option, because it is a 2.0 into 10 to the power 5 Newton meter square per coulomb leaving the surface, because the other one is entering the surface. The charge is inside the cube. So as the charge is inside the cube, obviously the lines of forces will be coming out of that particular cube which we are considering. So in this particular case, third one is the correct option. Let's take now the second case study question on this. Supercapacitor is a high capacity capacitor with a capacitance value much higher than the normal capacitor, but with lower voltage limit. Such capacitor bridges the gap between electrolytic capacitor and rechargeable batteries. In automobiles, bus, train, crane, elevator, such capacitors are used for regenerative braking, short-term energy storage, or burst mode power delivery. Supercapacitors have many advantages over batteries. They are low weight and generally do not contain harmful chemicals or toxic material. These can be charged and discharged innumerable number of times without wearing out. The disadvantage of that supercapacitor aren't well suited long-term energy storage. The discharge rate of supercapacitor is significantly higher than lithium-ion battery. They can lose as much as 20% of their charge per day due to self-discharge. So this was the passage, and now we'll take the questions based on this passage. Of course, for the case studies question, just after going through the text there or passage there, superficially, you can go to the questions to see what are the questions that you have to answer. Whether the answer to those questions lie in this particular passage, for that we can come back. Otherwise, there may be many questions which do not require the entire text there, although the reference of that particular question will be hidden there in that particular passage there. First question. The capacity of supercapacitor is very low. Second is medium, very high. And the fourth one is given as maybe any value. Now, if you look at this text there or the passage, supercapacitor is a high capacity capacitor. So obviously, if I have to answer this particular question, in that case, the capacity of the supercapacitor, we can take that it is very high. That is the correct answer there. Second question, supercapacitor makes a bridge between electrolytic capacitor and rechargeable battery. Second one is a single-use battery and electrolytic capacitor. Third one is electrolytic capacitor and dynamo. Fourth one is electrolytic and non-electrolytic capacitor. Again, for this particular question, if you see, the text has a reference to that. Such capacitor bridges the gap between electrolytic capacitor and rechargeable batteries. So in that particular case, here for this one, electrolytic capacitor and rechargeable battery. So that means is the correct option. Let's now take the third question. Supercapacitors can be charged and discharged. Options are few number of times, second once only, then third one is several number of times but less than rechargeable battery, and fourth one is the several number of times much more than the rechargeable battery. Again, for this particular case, if you consider, let's see here the reference. These supercapacitors have many advantages over battery. They are low weight and generally do not contain harmful material and these can be charged and discharged innumerable number of times without even varying. If you consider for this, the correct option is the fourth one, several number of times much more than the rechargeable battery. So this is for the third question. Let's now take the fourth one. Self-discharge rate of supercapacitor. Now the different options are given, and of course here in the text the reference to that particular percentage was also there. Like here the options are, first one is 10 to 20% of their charge per day, second one is 1 to 2% of their charge per day, third one is 0% of their charge per day, and the fourth one is your 100% of their charge per day. Now if you just take the reference to the text, it is mentioned here that they have 10 to 20% of their charge per day due to self-discharge. So here the correct option, if you consider now for this one, the first one is the correct one. 10 to 20% of their charge per day they get discharged. And the fifth one is supercapacitors are used for the different options are given: degenerative braking, then regenerative braking, then for a small appliances and long-term charge storage. Now, if you look at this, it is mentioned that regenerative braking. Okay. And this was also asked there in the question. So here it is for the regenerative braking there. And of course, the fourth one was also there, long-term charge storage. The disadvantage of that supercapacitor aren't well suited for long-term energy storage. Obviously, in that way, the fourth option is also ruled out because it is saying long time charge storage. So this is also not correct. So the second one is the correct one. Let's now take the next case study question. The physical properties of matter that causes it to experience a force when placed in an electromagnetic field is called electric charge. The electric charge is a characteristic that accompanies fundamental particles wherever they exist. The process of charging a neutral body by bringing a charged body near it without making contact between the two bodies is called charging by induction. The figure given below are showing the sequential steps of charged conductor permanently by using the process of charging by induction. Now here you can see the first diagram which is shown here. This is showing a uncharged body. Here in the second case, we are bringing a charged body close to it. So in this case, this is the charged body which is brought close to it. Now, if it is being brought close to it, in that case, charges will be induced. On the nearer side, it is the negative charge developed because the body has the positive charge. And on the outer side, there will be positive charge developed. That is the farthest side of that. And since it is Earth, the positive charges will be neutralized. Now the body will have only negative charge there. So let's see what are the different questions which are there. The first one is when a glass rod is rubbed with silk, it becomes positively charged, because now you know that if a body becomes positively charged, in that case, definitely the body must have lost electrons, because the charging in the body is due to the sharing of the electrons. It is basically the electrons which is moving, or it is the body is gaining electrons there. So if it is becoming positively charged, definitely the body must have lost electrons so that it becomes positively charged. So that in this particular case, the second option is the correct option. Electrons are transferred to silk. Because protons is transferred to silk, this is a wrong option, because protons are not moving from one body to another. And protons are added, definitely that is also not correct. Electrons are added, this is also wrong, because electrons, if it is added to a body, in that case it will become negatively charged. Since it is given that the glass rod is rubbed with silk and becomes positively charged, that means it must have lost electrons. Let's take now the second question. Which of the following method can be used to charge a metal sphere positively without touching it? The first option is connect the positive terminal of battery and float the other end of the battery. Now it was mentioned that body has to be charged without touching it. So obviously this is not the correct one. Rub it with a piece of fur. This is also not possible, because in that case the body will be touching it. Bring a negatively charged rod near it and touch it to the ground and rub it with a piece of silk. So this is fourth one is also not correct. Now here you can easily consider for this particular case, suppose you have a body and this body is uncharged, and now we are bringing a negatively charged body close to it. So this is suppose the body, and this is negatively charged. So as it is negatively charged, it will make the positive charge to get induced on the nearer end, and negative charge will be induced on the farther end. And if you earth this one, so these negative charges, they will flow to the earth, and now the body will have the positive charge there. So in that particular case, if it is asked to charge a metal sphere positively without touching it, so in that case the third one will be the correct option. Let's take the next question. We have two bodies with charges Q1 and Q2 on them. Then Q1 plus Q2 is 0. Now, if Q1 plus Q2 is 0, that means we are taking the net charge on the body to be 0. So here, if you take Q1 plus Q2 0, it means Q1 is equals to minus Q2. So what are the options? Q1 and Q2 are equal charges. They are equal. But they are of opposite nature, because the other option, if you see, Q1 and Q2 are equal and of opposite sign, this is correct one. Q1 and Q2 are equal but same sign, this is wrong. Q1 and Q2 are not equal charges, so this is also wrong. So that means in this one, the second one is the correct option. If you look at this particular question there, that if Q1 plus Q2 is 0, what does it signify? For this one, the reference to that particular text there, this particular text is not required at all. This particular text for the case study which is given there, it is referring to the method of charging a body by induction. Of course, the question which is asked is enough there to just have a reference of that particular phenomena, and you can answer this question without going through each and every line of that particular text. Let's take next question. If a body is positively charged, theoretically the mass of the object. Now we have just discussed that if a body is charged, it is basically due to the transfer of electrons there. If the body is losing electron, it becomes positively charged. If the body gains electron, it becomes negatively charged. So if there is any change in the number of the electrons there definitely the mass will also slightly change. Of course, mass of the electron is very less, so that is why it is the slight change in the mass there. So since it is said that the body is positively charged, it means it is losing electron. So the first option, it increases slightly by a factor, this is not correct. Decreases slightly by a factor of 9.1 into 10 to the power minus 31 kg. This is the correct one, because the mass of the electron is 9.1 into 10 to the power minus 31 kg. So it will decrease by a factor of this depending upon how many electrons have been lost by the body. Third option is remains same, so this is not correct. And the fourth one, may increase or decrease, this is also not correct. So the second one is the correct option. Let's now take the next question. The value of charge on a body which carries 30 excess electrons. Now we can use the quantization law. Q is equals to NE. N is your 30 here, and the charge on the electron is 1.6 into 10 to the power minus 19. So that means it is your 4.8 or 4.8 into 10 to the power minus 18. Okay, because it is basically 48 into 10 to the power minus 19. So we can write it as 4.8 into 10 to the power minus 18. So for this one, since it is the value of the charge on the body which carries 30 excess electron, it has surplus of the electron, so the body will have the negative charge. So in that case, the first one will be the correct option there. So this was our discussion on some of the questions of case study. In our next discussion, we'll take electrostatics and we'll take different case study questions on electrostatics.